showing the process I had to go through to cut these things to length, to face them to length, to do the outer surface, all of the problems I had there. The material, the raw stock, is not perfectly concentric, it's not perfectly straight. It is yeah, it's been a borderline nightmare to work with. Greetings and salutations, fellow YouTubians. My name is Terry Andrews Jr., also known as the J5 Guru. But today, I am El Monzo the Great, Terry's alter ego. I am the machinist on this project. So, a shout out to David Starling, kind of gave me the idea to make this video due to a post he put up about having raw track tip tube stock and not, you know, having a way to machine it. So I'm going to stand up here because my knees aren't what they used to be. So I am machining track tip tubes for the members of the Input Inc. team and the members of the Input Inc. team only. This is not for the faint of heart. If you can outsource this kind of process, by all means, do it. At 25,000 RPMs, it is extremely loud. I also have an air compressor over here that I have to use to blow out swarf and chips during the machining process. Yeah, so I'm going to try to just kind of cover the bases here. So this is the new and improved, let me make sure I'm in frame here. The new and improved version of the Johnny 5 track tip tube. Yeah, this has a couple features, and it has a quick release mechanism that, you know, that I designed along with members of my team. We worked collaboratively. This allows you to remove the tracks of the robot just by releasing a single pin. I'll actually show you that here. It's a quick release pin. Simply goes in and locks into place. This is the El Cheapo version, which just, you know, hey, you pull on it, it yanks out. You go for the Muy Grande version, which has a locking mechanism in there, so you have to actually depress the end. This goes in, and then now that cannot come out unless you depress that center portion. But yeah, and this pin goes through and it captures another piece which is attached to the tracks itself. And yeah, long story short, you basically, once you pull the pin, you can release the tracks. This has a cutout provision in here, which was necessary in order to get all the wiring through. This is a wire tunnel that me and Ramon, my teammate, designed. And this stays with the track tip tube, so all of your conductors and your data lines go through here and are able to be routed in here, and you don't have to worry about any of the wires touching, you know, being in contact or near any sharp surfaces in the track tip tube where it goes in. And yeah, that's what that does. Hole here, this is for the wires that go out into the cradle base of the robot. This gets chamfered and deburred. This may get some sort of an insert in here to further protect things. You know, hey, haven't crossed that bridge yet. But yeah, so this is basically it. This is 13.660 in length. This particular one is 13.664, so 4 thousandths over. Yep, fine, no problem there. The raw stock material for this length works out to about $125 just for this 3-inch OD by 2-inch ID nominal piece of raw stock. So it is not, yeah, it's not cheap. Okay, I'm going to put this somewhere where it can't fall on the floor where I could screw it up, because yeah, that would, this is a very expensive part. Okay, my CNC is not the latest and greatest, for God's sake. When I got it, it's a Max NC Max Pass 42, I think. I don't even think they sell them anymore, but when I got it, the people that owned the company at the time, yeah, this was a disaster. I had to redo the back plate. I had to, it had to be completely stripped down and rewired, and the original controller replaced with a smooth, a Gecko drive. It's running a smooth stepper off the computer, which is on the other side of the wall there. That's the wires going through. You probably can't see them. Anyhow, yeah. So this is not the fastest or the most rigid machine. I'm using a, this is a Bosch router that came with the machine. This is using a 125 diameter, so it'd be 0.125 inch diameter, single flute, high helix cutter designed for aluminum, plastics, things like that. From, I believe, Bits Unlimited. Actually, let me go get the thing here. Yeah, from drillbitsunlimited.com. These have a 1 inch length of cut, so they're very long for the length of cut. They're not super rigid. Trials and tribulations, I'll, you know, there'll be other videos where I post, but needless to say, I had many problems, and the learning curve to be able to machine these was quite difficult. I have managed to snap 1, 2, 3, or no, 1, 2, 3, 4. I snapped 4, and I clogged one of the flutes up with aluminum until I got my process refined. I realized what had happened was my cutting fluid. I was using cutting and tapping fluid, which is like 10 years old. And yeah, that was the problem, the cutting fluid. A big shout out, and I'm sure I'm going to butcher his last name, to my teammate Kyle Dedona, or Dedona. I apologize, dude, I butchered your last name. I got the first one. I got to pronounce your first name right, but yeah, Kyle. Yeah, our teammate, he conjured up all the G code for this. Okay, because it's not something that I'm real comfortable doing, and I don't, yeah, I'm not comfortable navigating the software. I believe it was produced in VCarve. He created all the G code, and we went back and forth on the speeds and feeds and depth of cut. I'm only taking a 5/1000th depth of cut. This is a long cutter. It is not very rigid, you know. Yeah, work with what you got here. So I said that I'm making this for my teammates. I won't be making these for the public. There's just no way. I wouldn't stand here at this machine, which of course you have to do. Yeah, I have to constantly be, you know, putting cutting fluid in there, which I'm using WD-40. That was the, yep, that was the secret sauce. WD-40 works great, but yeah, and it makes for good tool life, good cutting. But yeah, I wouldn't do this for under $20 an hour. Yeah, so the cost of the material plus me standing here for hour after hour doing this, you know, plus just to get to this point, because I had to do, you'll see I'll have other videos up by the time this is posted. Showing the process I had to go through to cut these things to length, to face them to length, to do the outer surface, all the problems I had there. The material, the raw stock, is not perfectly concentric, it's not perfectly straight. It is yeah, it's been a borderline nightmare to work with. The wall thicknesses vary as you go around. They vary from one side to another, so you'll see that the cutter is engaging quicker on one side than it is the other. But the main thing is, when I'm done, does the track tip tube precisely line up with the parts that are that are supposed to interface with it. And in this case, yes, they do. Is it perfect? No. But hey. So the fixture I designed myself, 3D printed out of PETG. It's working pretty damn good. I don't have a problem. So I just did one side on this. What I did is I numbered these as far as clock positions. So I start out at the 12 o'clock position and then work 2, 4, 6, 8, and 10. That was easiest for me to be able to keep everything straight and not screw anything up and not run the wrong tool path on the wrong face. I have one, but I can't use it. It's too large. An indexer to be able to spin this. So right now I'm just making sure that this piece is down in there. It is in my pins. Again, it's in another video, I think. I have 2 screws down here that allow me to be able to shift it to one side or the other. It's only a 2,000th variance, but still, that's my end stop on this side, that particular set screw, which is located down in here. Now there we go there. I realized during the design process on these particular pieces, and I'll show you here real quick. You may notice, let me see if this is in frame. I actually added a radius up here to these corners where it actually catches these corners here, okay? That was absolutely necessary because after I printed one off and tested it, I realized that if I left this at a hard corner, what this would do is this would actually cause the tube to rotate in here. So by making these radius, okay, that allows this to be off a little bit in any given direction, but still locate this within the fixture down here, within these pieces. So that way, if this is cantilevered, well, not cantilevered, but if it is, off a little bit, it doesn't cause the tube to turn. Okay, so first thing I'm going to do is I'm going to make sure, okay, I'm indexed to the 8 o'clock position, which means 8 o'clock is now up. Okay, make sure it's down in there, yep, and then putting my finger back here so I can feel when this starts to move, when it starts to grab a little. There we go. Right in that little gap that I have created on this. Oh, I suppose I should add that today is Sunday, January 16th, 2022, and 5:21 in the PM. Got a snowstorm on the way. Well, it's not really a snowstorm, geez, it's only 6 or 7 inches. So what I'm doing now, just starting to snug these up. So the name of the game here is get everything even. Don't have one side. Yep. So what I'm doing now is I'm just going through and using the same amount of tension and turns. Double check, make sure my gaps are consistent. You can see this one's a little bit higher. Okay, there. The idea is to hold it snug. But not crank on it too hard. This is 3D printed plastic after all. But there is quite a bit of clamping force on there. So I'm going to go ahead, do my human torque wrench thing. And I'm going to give it a final one here. Alright, now my final check. Make sure, yep, nice and solid. It's not moving on me, not going anywhere. Check to make sure it is located again. Yep, so I'm good to go. Alright. So this particular one, I have to go to number 8. Yep, number 8. So the 8 o'clock position. So I open my G code, I go into the 8 o'clock position folder, which is here. This particular one has 1, 2, 3, 4, 5, 6, because the middle wire hole, the large one, has 2 operations, and 7 because the dowel. So that'd be 1, 2, 3, 4, 5, 6, 7. 7 operations I have to perform just to do this one face here. So you'll notice about every 100th hour or so, I will hit it with a little dab of WD-40 with the brush. And then once it makes a single pass, I will blow out the swarf and let it continue. Again, it's a matter of just a fine amount of film. You get too much, you know, yeah, you want to blow that swarf out of there. You don't want a lot of thick oil or thick cutting fluid. So yeah, so here we go. Hearing protection on. I'm going to do the collar screws. And by the way, in between, I have this set up. Well, Kyle did, and he said, well, I can optimize the tool pass. I can make it so it don't come up after, you know, it doesn't do a safe Z lift after every move. And actually, I need that time to be able to get cutting fluid in there. And also, it's broken down to where if something happens, like I break an end mill or something, I don't have to go back and rerun an entire set of G code. I can just jump to the particular one that I need and just rerun it. And also when that happens, I have to rehome everything, so and reset the Z height for the new end, cutter end mill. So okay, here we go. Let me see. I check my time here. 20 minutes and I haven't even fired up the machine. Okay, so here we go. Collar screws. Yep, those would be these two right here. The collar screws, I'll go ahead and do them first. So, collar screw, go to the G code. Wait for the G code. Yep, I'm using Mach 3 here. I know they got newer versions out, but hey, ain't broke, don't fix it. So, using my little brush to coat the end mill. Over here. Here. All right, it's gonna get loud, folks. 25,000 ribbons.